Welcome to Eagle Complete course. In this course, I will explain more detail about one of Eagle's features called Autoroute. The Eagle Autoroute is a 100% router. This means that boards which, in theory, can be completely routed will indeed be 100% routed by the Autoroute. The Eagle Autoroute is based on the rip-up or retry algorithm. As soon as it cannot route a track, it removes pre-routed tracks or rip-up and tries it again or retry. The number of tracks it may remove is called rip-up depth, which is decisive for the speed and the routing result. This feature has some rules. Here's some of them. It works on a routing grid with minimum size of 0.02 mm. It works at any placement grid. SMDs are routed on both sides. The preferred track direction can be set independently for each layer. Simultaneous routing various signal classes with various track widths and minimum clearance. And rip up and retry for 100% routing strategy. The Autoroute is controlled by a number of parameters. The values in the current design rules, the net classes, and spatial Autoroute control parameters all have an effect. Before we start with the Autoroute, there are some parameters that have to be defined. First are the design rules. The design rules need to be specified in accordance with the complexity of the board and of the manufacturing facilities available. Second is the track width and net classes. But if no spatial net classes are defined, the values from design rules apply. First, we will set the DRC or the design rules checker. You can click Edit and select Design Rules, or click this symbol over here, then select the Clearance tab on the top of the window. Here the clearance between each different signal will be 0.6 mm. Then, we will move to the Distance tab. For the drill or hole, I will also set the minimum value to 0.6 mm. Now, we're going to set the size of the track width and the drill. For the default size of all tracks, as well as the minimum drill, I will use 0.6 mm. Then, for the rest, I will keep it default. You can click Apply to apply these rules to your design, or you can click Check to check the errors on your design, or simply click Select to save these rules. The net classes feature lets you select different widths for each net. This is useful if you, for example, want your power traces to be thicker than your signal traces. In this example, we'll set up a new net classes for our ground and VCC net. Then, we'll set the default width for all the other nets. To set up a net class, go to Schematic View and click Edit. Then select Net Classes. After that, click the Rules tab on the top side of the window. Here, for the default net, the minimum width will be set to 0.6 mm. Then, I will make another net called VCC. We can go back to the Classes tab, then click Add. Then change the net classes name to VCC, then go to the Rules tab again. Its width will be 0.8 mm. The next net I will make is the ground net, and the width will also be 0.8 mm. Now, we will set the member of each net list. Then, click OK. After defining the new net class, we know that by default, all the nets will have the default net class. If we want to change to another net class, choose the info icon here. Then select here and change the net class. Then click OK. The net classes must be set before we route your board. After that, we're ready to move to the board layout editor to run the Autorouter. Before you run the Autorouter, you can set your component placement as you desired. After that, click this icon over here to open the Autorouter main setup window. As you can see here, each layer has a drop-down menu to set the preferred direction. If you need a specific direction of the route, like vertical or horizontal, select it for each layer, or you can just set it to auto. Here, the NA means the Autorouter will not use this layer. This symbol indicates horizontal direction. This symbol is for vertical direction. This is for 45-degree diagonal, and this is for the 135-degree diagonal. The star symbol here means none. Then, the effort option defines how the Autorouter will work. Higher effort will take more time and will provide more routing variance. If the automatic grid selection is on, the Autorouter chooses its own values. Then, The variant with top router activates the new top router that calculates the layout with another routing algorithm. Typically, the computational effort is larger, but usually provides smoother result with fewer vs. The number of threads means how many threads of the CPU you want the Autorouter to use. This surely will affect the time it takes to finish. You may use the Load and Save As buttons to load a different parameter set from an Autorouter control file, or to save the current settings for further projects. To process the Autorouter, click Continue, and a number of different routing variants are calculated. The Routing Variants dialog opens. Here, you can modify the parameter set of each variance or delete or add variants in the list. Then, click Start to begin the process. Now, you can wait until the Autorouter complete your routing process. After all the auto routing process is done, you can choose which variants you will use for your design. If you would like to check and maybe adjust the individual routing parameters before, click this button. In the Advanced Option dialog, you can review and modify the routing parameters. Click Duplicate or Delete in order to copy or delete the selected variants. If you're done with the Autorouter process, you can click Evaluate if you still want to save this parameter for later, or you can just click the End Job to end the Autoroute process. So this is the result for the Autorouter process. If you may be not too satisfied with the result, you can retry the auto-routing process with the higher effort. After all the process is done, you can use the DRC or Design Rule Checker to check this design. If there is an error or warning, then you can fix it manually.